Welcome everyone, I'm Brian Walsh, and in this lesson we're going over stoichiometry. So we touched on stoichiometry in a previous lesson when we learned how to convert between grams and moles of a substance. But in this lesson we're going to cover stoichiometry in much more detail.
The key to converting between one substance and another is the balanced equation. And that's because the balanced equation is a molar ratio of one substance to another substance. For example, in this balanced equation, we can see that for every 1 mole of propane that reacts, 5 moles of O2 react. So this gives us a 1 to 5 ratio of propane to O2. And we can use this ratio as a conversion factor in our calculations. So we have 1 mole of C3H8 per 5 moles of O2, and we can flip this and use it the other way also. So we have 5 moles of O2 per every 1 mole of C3H8. And this ratio relationship works regardless of which side of the equation a substance is on. For example, for every 5 moles of O2 that react, 3 moles of CO2 are formed. So the ratio of O2 to CO2 is 5 to 3. And we could write that conversion factor either like this or like this. Now that we know that the balanced equation is a molar ratio, let's see how to convert from moles of one substance to moles of a different substance. So this question asks, how many moles of CO2 are produced when 4 moles of C3H8 react? So we've been given moles of C3H8, and we're going to convert those moles to moles of CO2. So we're going to start our calculation with our 4 moles of C3H8. So now we want to convert from moles of C3H8 to moles of CO2. And we're going to do it by using our molar ratio here. So we can see that we have 1 mole of C3H8 for every 3 moles of CO2. So we have 2 possibilities for conversion factors. The key to making sure that you use the right one is to set it up so that your units cancel. For example, if we try to use this conversion factor, we can see that we have moles of C3H8 on top here and moles of C3H8 on top here. So these moles of propane and these moles of propane won't cancel. So we don't want to use this conversion factor. If we use this one instead, we can see that we have moles of propane on the bottom, and those can cancel with the moles of propane on the top, which would leave us with moles of CO2 as our answer. So this is the conversion factor that we want to use. So we set this up so our moles of propane on the bottom can cancel with our moles of propane on the top. So these cancel with these, leaving us with moles of CO2. And because moles of CO2 are what we're trying to find, we can go ahead and do our calculation now. So we multiply 4 times 3, divide by 1, and what we get is 12 moles of CO2. In previous sections, we learned how to convert between grams, moles, and atoms or molecules of a single substance. So within this particular substance, I can convert between any one of these things. Or within this substance, I could convert between moles, atoms or molecules, or grams. But until now, we haven't seen how to convert from one substance to a completely different substance. And that's exactly what the balanced equation, the molar ratio from the balanced equation, allows us to do. We just learned how to convert from moles of one substance to moles of another substance. But what this diagram shows us is that we can convert from grams of one substance to grams of another substance, or even molecules of one substance to grams of another substance. And the thing that makes that possible is the balanced equation. Now let's see how we can convert from grams of one substance to grams of another substance using our same balanced equation. So this question asks us how many grams of O2 react to form 125 grams of CO2. So we've been given grams of CO2 and we're asked to find grams of O2. So we need to convert grams of CO2 to grams of O2. So if we look back at our diagram, we've been given grams of CO2 and asked to find grams of O2. So we need to convert from here to here. So our first step is going to be convert grams of CO2 to moles of CO2, and we do that by using the molar mass of CO2. And when we use our periodic table, we calculate the molar mass of CO2 at 44.01 grams per mole, and this is rounded to 4 significant figures. So we start our calculation with grams of CO2, and we're going to convert these grams of CO2 to moles of CO2. And we do that by using our molar mass of CO2. So we make sure to set up our conversion factor so that our units cancel. So we have grams on bottom here, which can cancel with the grams on top. So these grams cancel with these grams, and now we have moles of CO2. So now we're at this point of the diagram, which means the next step is to use the balanced equation to convert from moles of CO2 to moles of O2. So if we look at our balanced equation, we can see that we have 5 moles of O2 for every 3 moles of CO2. And again, we set up our conversion factor, making sure that our units cancel. So we have moles of CO2 on the bottom, which can cancel with the moles of CO2 on the top here. So these moles of CO2 cancel with these moles of CO2, and now we have moles of O2. So now we're at this point in the diagram, which means that our last step is to convert from moles of O2 to grams of O2. And we do that by using the molar mass of O2. And when we use our periodic table, we calculate the molar mass of O2 to be 32.00 grams per mole. And again, we set up our conversion factor so that our units cancel, which means we have moles of O2 on the bottom to cancel with our moles of O2 on the top. So these moles of O2 cancel with these moles of O2, which leaves us with grams of O2. And because grams of O2 is what we're trying to find, we can go ahead and do our calculation. So we multiply 125 times 1 times 5 times 32, and what we get is 20,000 grams of O2 on top. And we keep the grams of O2 because it's the only unit that hasn't been canceled on top. Now we calculate the bottom. We say 1 times 44.01 times 3 times 1, and what we get is 132.03. And notice that there's no units here because all of the units on bottom have been canceled. So we divide 20,000 by 132.03, and what we get is 151 grams of O2. Now let's look at how to convert between grams and molecules, and we're going to use our same balanced equation. So this question asks how many molecules of H2O form when 75 grams of C3H8 react. So if we look at our diagram, we've been given grams of C3H8 and asked to find molecules of H2O. So we need to go from here to here. So we can see that the first step is to convert from grams of C3H8 to moles of C3H8, and we do that by using the molar mass of C3H8. And when we use our periodic table, we calculate the mass of C3H8, the molar mass, I should say, as 44.09 grams per mole. And this is rounded to 4 significant figures. So we start our calculation with 75 grams of C3H8, and we want to convert from grams to moles, so we're going to use the molar mass. So we set up our conversion factor, making sure that our units cancel. So we have grams of C3H8 on the bottom, grams of C3H8 on the top. So those units are going to cancel. And what we're left with then is moles of C3H8. So now we're at this point on the diagram, and we can see that our next step is going to be to use the balanced equation to convert from moles of C3H8 to moles of H2O. And if we look at our balanced equation, we can see that for every 1 mole of C3H8, we have 4 moles of H2O. And again, we set it up so our units cancel. We have moles of C3H8 on the bottom, moles of C3H8 on the top. So these cancel with these, and now we're left with moles of H2O. So now we're here, and the last step is to convert from moles of H2O to molecules of H2O. And we're going to do that by using Avogadro's number. So we set this up so moles of H2O on bottom cancel with our moles of H2O on top. So our moles cancel with our moles. And now we're left with molecules of H2O. And because molecules of H2O is what we're trying to find, now we can go ahead and calculate. So we multiply 75 times 1 times 4 times 6.022 times 10 to the 23rd and divide by 44.09. And what we get is 4.1 times 10 to the 24th molecules of H2O.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.